name's Kirby Williams. I'm the president of the Starrington Garden Club, and our club was founded in 1926. But our club's purpose is twofold, and the first is to really educate and encourage interest in the environment, conservation, and community projects. And the second, no surprise, is to stimulate the love of gardening and the knowledge of gardening. But under the first part of our purpose, we are so happy to welcome our speaker, Dr. Matthew Kotchen, who will speak on climate change, the perfect problem. Dr. Kotchen is a professor of economics at Yale University School of the Environment, a researcher for the National Bureau of Economic Research, and he serves on the advisory committee of the U.S. Environmental Protection Agency. And most importantly, he is the son of our beloved member and community neighbor, Deb Kotchen. So Matthew's talk will focus on the problem of climate change and the realistic solutions from an economic perspective. And please join me in welcoming Dr. Kotchen.
Hello, everybody. Thanks for the invitation. Thanks for all of you for taking some time out to come and listen to this talk. It is a pleasure and a privilege to come to places like this and share some of the things that I think about all the time and teach with people who are actually not just in the university. It's also a pleasure for me to give this talk because not only is my mom here, Debbie Kotchen, but my sister is here too. So I get the two of the women in the longest time in my life from whom I've learned a lot and continue to learn. So it's nice to actually have them both here. The title of the talk that was mentioned is also a title of the presentation that I gave here. It might have been 7 or 8 years ago, I think, to the men's club or men's group. And I forgot that was the title that I gave that time to give it again. But I do want to so the talk is, I assure you, a different talk because the times have changed, but many of the issues are the same. And the title comes from calling it a perfect problem is, some of you may have read or remember Sebastian Unger's book, The Perfect Storm. And this was a wonderful book, or actually if you haven't read the book, maybe you've seen the movie that stars George Clooney. And it's all about a sort of fisherman from Gloucester, Massachusetts, who goes out fishing. And in the meantime, unbeknownst to them on the boat, there is this storm brewing. And in the movie, you go back and forth between seeing what it's like to be out fishing and catching fish, and then the sort of mission control of meteorologists watching this storm. And the idea is that they call it the perfect storm because all these conditions, then many of you are sailors or boaters, of like barometric pressure, low pressure systems, different things, were all sort of coalescing around, creating the circumstances for what they refer to as like the perfect storm. The unlikely circumstances of all these things coalescing at the same time to create a really terrible storm. And of course, the reason why this was such a great book and a blockbuster movie was not because they were showing video of the meteorologists looking at computers the whole time, but because those on the boat didn't know this storm, and it was about their struggle because they were unaware. So I think this sets up, because I'm going to sort of talk about somewhat here why I think climate change is also the perfect problem, because it's the constellation of all these things that we as humans are actually really terrible at solving. So it's a really, really difficult problem, and in that sense, it's like the most perfect problem. But there is sort of a hopeful message out of the talk, because I don't think that we're like passengers on George Clooney's boat where we don't actually know the circumstances. Although maybe it's not as glamorous, we're sort of know what the meteorologists are seeing, and we see this coming, and there are things that we actually can do about it. So that's the motivation for why I think of it as the perfect storm. But really, this is going to be a talk about the economics of climate change and economics and policy of this issue. And although I am going to talk about the policy and the economics primarily, I do think it's important to start with just some level setting about like what the issue is and why we're concerned about that. And I think that you can get at this with pretty much one slide here. So for those of you, there are going to be some graphs in this presentation, but you don't have to worry about it or go into any symbol shock, because I will walk you through them and keep you up with what's happening here. This is a graph where we have on the horizontal axis here, this is year. So we go from 1880 until 2020 here, and we actually have data up until 2021. And what this graph plots, these bars are, let's take the average temperature, and this is the average temperature on the planet for the entire, from 1900 until the year 2000, so over a 100-year sequence. And let's just take the difference of each year's temperature from that century-long average. And so this first one, these blue ones, are the ones where it was actually a year where the temperature globally was on average beneath the average for the whole century. And what you can see is that it was less than the century average up until the 1940s or so, where it mixes a little bit, but things really start to take off here around 1970. And you can see that we no longer have temperatures that are even close to below average anymore. And this is a clear trend where it is now hotter, warmer in terms of average temperature throughout on the planet, everywhere, so this is the global average, than it was a century ago. And this is sort of just measurements of what global temperature is. And so then what is sort of like the problem? It is true that temperatures have changed globally over time and over long periods of time. But this other curve here is plotting, and on this axis, this is the atmospheric concentration of carbon dioxide in the atmosphere. So we have measurements of this going back from recent measurements in Hawaii, which I don't know exactly what year they started, probably around mid-century. But then you can go back in time a little further and look at bubbles that are actually captured in ice and measure the carbon dioxide concentration of what it was before we actually took measurements. And you can see that this is tracking quite closely to this temperature change. And in ways that you could have an entire course, in fact, we have entire courses of this at Yale, about there's a big sort of body of science that relates causality between why is it that this rise in atmospheric concentrations of carbon dioxide are driving this temperature change. And for purposes of this talk, and maybe we can talk about it a little bit afterwards in the Q&A, my expertise is not on the science, but the science is pretty clear that this line of concentrations is driving the temperature change. And the reason being that there's just some basic physics, and all the other candidate explanations don't explain it. And so this is human activities that are actually causing a planetary shift in temperature, which then has other implications. And I'll take you through some images here of just saying, like, so we have climate change, temperatures are going up, why do we actually care about this? Well, the impacts here, one of them are that we're going to have rising temperatures, as I just said, but also in ways that are quite important for both natural systems and humans are heat waves. And this is going to be a tour of just some images where if you sort of follow the news the last year or two, none of this is going to be shocking. You see these things becoming more frequent and more severe. Another one many people here in the town of Stonington probably think about or worry about themselves are rising sea levels. Higher temperatures lead to expansions of water, and we've got big oceans with a lot of water. That leads to rising sea levels, and so does the melting of large ice sheets. Other consequences are increased storm frequency and severity. We've seen these actually just in the last week with more storms and damages in the southern US. We've got changing patterns of precipitation and drought. This is both places that will get less rainfall and less snow and also more. And I think one of the big things here is you're going to have much more variability. And we've seen this actually in California in this past winter in terms of more precipitation. Also shifting agricultural productivity, where we're changing the sort of concentration of carbon dioxide in the air, changing temperatures, changing water, having heat waves. This affects agricultural productivity. We get increased frequency and severity of wildfires, and we've seen these recently as well. And there's threats to ecosystems and species stability. And part of the issue here is it's the rate at which this temperature is changing. Many species cannot adapt, both flora and fauna cannot adapt to these changing timing of the spring and in the fall and temperatures. There's direct human health consequences. When you don't have colder weather, diseases can spread in different ways and in different areas. We have global conflict and migration. There's been a whole slew of recent papers that have looked at sort of trying to figure out the climate-based or environmental basis for many of our increasing conflicts around the world, and there's evidence of it. So this is the bummer part of the talk, because I'm going through it, I'm telling you about all these consequences, but these are real, and you see these covered with increasing frequency, and we actually these are not just issues that are in the far future, but things that are actually starting to impact us now indirectly. So why is this a problem? We kind of know about this problem. For at least 30 years, we've had international organizations that are focused on trying to come up with solutions and address climate change. Why is it that it seems like this problem is not getting better, but is getting worse? And what I'm going to go through is I'm just going to go through sort of in a very broad way and focus on 6 different characteristics of this problem that contributed to it being what I refer to as the perfect problem that make it particularly difficult for us to solve. And the first one here is that emissions of carbon dioxide or other greenhouse gases, things like methane, are basically not something that just comes out of like factories and are pollutants. This is not like chlorofluorocarbons and the ozone layer, where there's a particular technology, a particular chemical for particular things that we could actually solve. The issues associated that generate greenhouse gases are involved in every single thing that we do all the time. And what this pie chart shows here is this is sort of, for Americans, this is where our individual, on average, carbon dioxide emissions comes from. And you can see the food that we eat, producing that food, delivering it, fertilizer, accounts for, on average, 14% of our personal carbon footprints. Home heating and cooling is 17%. Other home energy use, things like your televisions, your computers, entertainment types of things, 15%. Embodied in the things that you actually buy. There's energy that goes into them, and those chemical process, this generates emissions, that's 26%. And transportation is the largest one. When we drive our car, we burn gas, which is fossil fuels, which creates carbon dioxide, which contributes to climate change. And even if you have an electric car, many people forget that electric car actually, right now, well, electric cars need to be run on electricity, and we often burn coal or natural gas primarily to generate that electricity. So the ads that you see about emission-free cars are actually not emission-free. It doesn't come out of your tailpipe. It just comes out of power plants. So this makes it difficult because we're all part of this problem, and we're all small, but everyone adding up contributes to the problem. That's one element that makes this a difficult problem. Another one is the timing of this problem. So this is a railroad track, and this is a metaphor for what you should have in mind for when you think about how people compare costs and benefits or consequences of activity. When you look down that railroad track, you see that it goes far into the distance and it gets smaller and smaller. Well, this is the way that people generally think about things that happen far into the future. They care about less than the things that they happen now. The technical term in economics for this is that we discount the future. For those who are involved in finance, or the discounting the present value. Things in the future tend not to be as much of concerns as things that happen in the present. And some of the issues with climate change are that in the worst consequences of it are things that are going to happen farther into the future, a decade now, future generations. But in order to address this problem, we have to have policy changes and do things differently that involve cost now. So one of the challenges is addressing climate change is we got all these costs here for all these benefits really far down the line that actually don't have as much consequences. And it's really difficult for us, both as individuals, to solve problems in our own life that have that characteristic. Like, for example, if you exercise now, it may be costly for you, but you have health benefits that are far into the future. And I suspect many of you have challenges exercising as much as you actually think that you would. Well, the same applies for us in terms of thinking about problems like this, and for governments to also address these problems. Compound the fact that we have an intergenerational issue where the costs are for us now, the costs of taking action now for benefits for future generations. It's difficult to solve that problem. And now layer on electoral cycle for political leaders that need to be elected or re-elected now and not address the problems that are further, and it makes it difficult to solve these long-term problems like climate change. Number 2, and this is the solutions require public policy. And I've got the different sort of mascots here of the two political parties. This is not going to be a partisan talk in any way. But what I will say is one of the things, and I'll talk about this a little bit more, I'm an economist, and fundamentally climate change, and there's no economist who disagrees with this, regardless of whether you're a Democrat or Republican or where you come about, climate change is a market failure. And it is a market failure because what happens is every activity that we engage in that is associated with climate change is associated with emissions. And those emissions have costs to society. And those costs are not taken account by those who engage in those actions. That is a classic market failure that we've known about for over 80 years since Arthur Pigou, a British economist, first identified the notion of an externality. And the way to solve externality problems, the only way to solve externalities on a large scale, is to have policy interventions that change the rules of the game in order to correct market failures. This is, I just want to be clear, economics 101 and not politics, okay? But when you notice that, if the solution to climate change involves government action, the way people tend to perceive climate change and whether it's a problem, if it always maps into needing a government intervention or policy, people can't help but view the issue through their partisan lens because the solution requires government policy. And so you can see there's lots and lots of evidence, much of which, some of the best evidence, comes out of Yale in our project on climate change communication, where we do surveys, and you see big partisan differences, both in terms of whether or not you think climate change is a problem and what you should do about it. And my point here is it is contributed to because this is a challenge that requires government, and so the way that you think about it can't help but be influenced by the views that you have about the role of government in society and in market economies. Add to that one of the big issues in terms of climate change is the need for an energy transition. And if you wanted to think about vested interest in investment in infrastructure that we have a lot oriented towards the production, the consumption of fossil fuels, and those vested interests understandably are big actors in the political process in trying to influence outcomes. That's number 3. Number 4 is that this is a global challenge, and this is probably the scariest part of the talk here, but this is scariest because it involves some analysis here. Some of you may be familiar with this, but climate change is a global problem, which means that the only way to address this problem is to somehow have coordination or collaboration across sovereign nations on a planet. Many of our environmental problems that we've had tremendous progress in solving since the 1970s are because we have a regulatory entity over local pollution, like our own water quality or our own air quality. But climate change is one where the emissions of one country has consequences for other countries, and these countries need to come together to somehow try to solve this problem. And this is a very difficult problem, and maybe I'm not going to spend time going through this, but the way to fundamentally understand this problem is by thinking about crime shows on TV. Okay? Some of you may be familiar with something called the prisoner's dilemma, which is a basic economic concept in game theory. And the prisoner's dilemma is consistent with the strategy of police officers where you catch two alleged, I want to say alleged here, criminals, and they go and they kind of caught them sort of in the act, but they don't really know what was happening. So they take them in, they take them down to the station, and they interview them. But everyone knows you would never interview them both in the same room. You'd split them into two separate rooms. And what you do is you try to cut deals with the two, where you say to one potential criminal, well, if you confess, you'll get a more lenient sentence and we'll lay it all on the other guy. And you tell the same thing to the other guy. And both criminals know that they would be better off if they could keep quiet and not say anything. But the way that they set up the potential deals is that both of them are going to be better off regardless if they actually confess, because then they get a better deal. And this is basically that prisoner's dilemma that I just talked about. I was planning to go through this, but I think in the interest of time and having discussion, I'm not going to go through this, is the same thing. I personally have been involved in international negotiations when I was at the Treasury Department about financial aspects of international climate agreements. And that prisoner's dilemma is the same game that countries are playing. It is a prisoner's dilemma type of idea because every country would be better off if they didn't take action, but other countries do, okay? And because of that feature, everyone wants to free ride on the other countries potentially doing it and them not doing that themselves. And you end up in a prisoner's dilemma type outcome because basically both countries prefer to end up in they choose to be in a high emissions outcome instead of a low emissions outcome, despite the fact that they could both be better off if they collaborated and reduced their emissions. But it's difficult to sustain. And why is it difficult to sustain? Well, another movie, A Beautiful Mind, about John Nash, it's because it's not a Nash equilibrium for them both to collaborate, and so both countries don't. And you see this playing out in international environmental agreements, and this makes it quite difficult. Challenge number 5. This one is a mismatch between where the emissions are taking place and where they've historically taken place and where the consequences are taking place. This is a figure taken from the Climate Impact Lab, which is a large consortium of both natural scientists and social scientists that do wonderful research to quantify the impacts of climate change. And they have a lot of different things that you could look at. I've just picked out one. This is a graph here that's plotting forecasts in the end of the century, what the increased mortality will be across different countries because of higher temperatures, and then plot that as a percent of each country's GDP. So these countries, you see the consequences here where it's dark. These are around it's forecasted that 20% of GDP, and this is without adaptation between now and then. It'll probably be less because there will be adaptation to the extent that countries can afford to adapt to things like air conditioning from heat waves and higher temperatures. But this is where the mortality consequences are going to be greatest. Well, if you actually took the emissions of these countries here where you see it worst, I bet the sum of their emissions is probably less than California's alone. Okay? So the places that are causing the emissions are not the places where the consequences are going to be the greatest. This is both because of geography, where temperatures are going to be highest, but it's also because of incomes. We are lucky, and we're in a place where, if sea levels were to rise here in the borough of Stonington, which many of you probably think about it, while these would be like very difficult events, these are not likely to be catastrophic, life-changing, fundamentally like immediate risks for those who are fortunate enough to live in the borough. In Bangladesh, that's not the case. So what happens is the countries that are emitting are actually not the places that experience the consequences, so it's difficult to mobilize the support or the willingness to really take action. Having said that, if you were to forecast out in another 50 years, the big emitters historically are not going to be the big emitters in 50 years. The trends in China, India, Brazil, these are going to be the big emitters of the future, whereas I'll show you in a minute, the emissions in the United States, for example, has actually been declining. Number 6. 6, and this is the sort of like the linkage here to sort of the economics that I want to share, is it's a difficult problem because we don't know what to do and we don't know how much to do. And I think that an easy way for me to communicate this is to something that is maybe more salient and has been on our mind, which we can think about COVID, for example. Here's something that was not an immediate, not a long-term problem, but a more immediate consequence. And of course, many of us were worried, everyone sort of scared, but you could think about what were the scientists saying about COVID, and what did many actually people sort of say? Well, there was this risk of spread, and there were all these health risks, and if you ask an epidemiologist, and many people did and listened to them, what was the recommendation? Well, an epidemiologist's job is to understand the spread of disease and prevent it from happening. So their recommendation was everybody should wear masks all the time, not go out, and we should shut everything down, okay? Some countries did that. Some people, at first, many people did that, but over time, more and more people grew to think about, well, I don't dispute the science or the concern about the issue, but there are actually costs associated with shutting things down too. There are health consequences of people not earning their income. There are health consequences about people staying inside. So in that short narrative, I transitioned the issue from being a fundamental science question to being an economics question, which is about trade-offs. There are costs and benefits. And how do you actually balance these? And this is the domain of economics. Many people think economics, and when I teach this to students, some come in and say, you think economics is all about making money. Well, part of it is, but the bigger part of public policy economics is about costs and benefits and trade-offs and how you actually make decisions. And so thinking about the costs and benefits of climate change is difficult. Okay, but it turns out that one feature that I want to highlight here is something referred to as the social cost of carbon. And this has been referred to as the most important number that you've never heard of, okay? And I think that's probably true for many, but after this talk, I don't think that you at least you could decide if it's the most important number, but at least you will have heard of it. And what this is this is the monetized damage of emitting 1 ton of CO2 into the atmosphere. And you can do this for different years. Just to give a sense, people talk about a ton of CO2. What does a ton mean, just to have in your mind? On average, for the vehicle miles traveled for a car that Americans drive, we emit ourselves on average about 4.5 tons of CO2 per year. So that should just give you a sense. It's about a quarter of the amount of CO2 emissions that you emit from driving the car in the year. And this notion, so this says if you all just took a pulse and popped a ton of CO2 into the atmosphere, it contributes to climate change and has the consequences that I've talked about. So if we think about this from an economics perspective, what are the consequences of that? Well, it turns out that there are very sophisticated models called integrated assessment models, the earliest one of which, my colleague at Yale, William Nordhaus, won the Nobel Prize 3 years ago for pioneering these techniques, for studying the macroeconomy and estimating what would be the consequences of this ton of emissions. And these are calibrated models that have climate aspects, they have economic aspects, they estimate the damages and how the emissions affects agriculture, how it affects productivity, increased storm activity. It's complicated models. Back in about 2010, he had a version of his analysis, although he started working on this in the early 80s. And this is what got him the Nobel Prize, that ton of CO2 emissions causes $51 of damage in terms of damages around the world. And through his work and other works, at about the same time in 2011, the US government conducted a whole big consortium of analyses and involved 7 different agencies of the government to estimate this number. And they came out with a number which for our purposes is similar enough, is about $51 per ton. So this is the damages associated with a ton of emissions. It also suggests if you undertake a policy to reduce emissions, it's the benefit per ton of avoiding that damage. Okay? So now we've done what a process we refer to as non-market valuation. There's no market for CO2 out there where you could look at prices in the same way you buy bread or gasoline, but we have an estimate for what those costs are or what the benefits are. Fast forward now to just this past year, there's been a large group at Resources for the Future, which is a think tank in Washington, D.C., that has updated this analysis, and they now come up with a number based on updates to science and better calibration of these models that put this number at closer to $185 per ton. And the US EPA has reinvigorated the group and come up with a new process to estimate this number, and they come out quite similar at about 190. These numbers are kind of going back and forth, and the precise numbers are actually not critical. But you can see that over just about 14 years, we've had a significant increase in how we estimate these damages. Going back to that scale of the benefits and costs, what this tells us is that if we're thinking about climate policy or reducing emissions, we now have a way to quantify the benefits associated with doing that. So now let's think about the costs. What are the costs of reducing emissions? Well, some of the good news about costs here is I want to show you a little bit about what's been going on here in the US. So this is a graph that is showing some characteristics of the US electricity sector. which is where a significant amount of the greenhouse gas emissions come from in the US. And what this is going from 2000 to, I think this is actually to 2021 or 2020, this is showing how much electricity is consumed in the US. And it's actually kind of been creeping up. It's relatively flat, but it has not been dropping. If we actually have this transition to electric vehicles that many are arguing, you expect this number to go up quite significantly in the coming years. But our electricity consumption has not been going down. But in a way that, if you think I've been the bearer of lots of bad news here, here's a piece of like really good news. This is what's happened to the emissions over the same time period from the electricity sector. It's dropped significantly. And how has it dropped? Well, the primary feature, this graph is telling you the sources of our electricity generation, where they're coming from. And the big story here is we have an increase in wind and solar over this time, which does not generate greenhouse gas emissions. But the real big story is the increased use of natural gas. And I say this was the transition of let's talk about costs. This is actually one that wasn't costly at all. This was technological innovation and breakthrough of hydrologic fracking, which is a way to more cost-effectively extract fossil fuels and natural gas. And basically what this story is over the past, 20 years has been a big story in the electricity sector of gas has outcompeted coal and replaced it, which has about half the CO2 emissions. So this is a success story, and it also is a warning about what we should be working on and thinking in terms of how to deal with this issue in the context of other countries. As they're constructing new coal-fired power plants, we should find ways of actually making sure that if they're going to use fossil fuels, that they actually are shifting towards natural gas instead of coal for this reason. So this is like costless emission reductions. This is the easy stuff. Another remarkable story that I want to show here is this graph. I realize these numbers may be a little small and hard to see, but the cost of renewable electricity generation, this is from wind and solar, has just been like the story of the last decade plus. So this is 2009, this is 2019. So in fact, this is underestimates if I was to look at 2023. This is a few years old here. But if you actually look at what's been going on here, part of the story that I just told is this is the cost of natural gas peak power plants. These are the ones that are used to follow load or electricity. That cost has decreased over this decade by 37%. Other sources of natural gas, this lower one is 32%. This is for meeting base load of electricity. But the real story here, and the remarkable story, this is unbelievable, is look at what has happened to the price of solar photovoltaics. Just in this decade, the price has dropped by 70%. This is the levelized cost of producing a kilowatt hour of electricity from solar from 2009 to 2019 was 70% less. And wind is even more shocking. It's declined 89% over a decade. You're starting to see now wind and solar being sort of installed in lots of places, and it is competing on a levelized cost now more than coal. It's cheaper than coal. Now, there are issues associated with this because it's intermittent. It depends when the sun is shining and when the wind is blowing. So storage is an issue. But this is the kind of thing that makes the costs of addressing this problem less and it indicates is a hopeful message in terms of our ability to do it. Despite these stories, I want to actually convey that it's not enough, okay? We have a lot to do as a globe and as a country. And to show you what's going on, this is a graph where we've got, goes from 2010 to 2050. And what we're showing on this graph here is this is the forecast. This is annual emissions, okay? This is a baseline, but this baseline maybe is not that relevant because this line here is suggesting what our emissions are going to look like out to 2030. So this is not a very far time horizon with the current policies that are in place. So with the policies that we have in place, we've bent this curve a little bit as a globe. This is where we're expected to actually go now. What these curves are telling you are different ways to look at the Paris Climate Agreement, the international agreement about what countries have said they're going to do in terms of reducing their emissions. It's questionable whether or not we're going to achieve that, but let's take the best case scenario. And there's an unconditional scenario, which is you just sum up all those pledges, and a conditional scenario, because there's lots of deal making to try to solve that prisoner's dilemma type problem that I did before, which says, well, we'll reduce our emissions by this percent, but if you actually help with providing financing to this amount, we'll reduce it more. Or we'll watch what you're doing, and if you do what you're saying, we'll actually do it. And you'll see that the Paris Climate Agreement has actually even bent the curve further. Let's take even the most optimistic scenario. But even in that most optimistic scenario, what path are we headed on? Well, this is still emissions increasing. And the agreement that 198 countries of the world actually made was to try to limit CO2 emissions to 2 degrees. And that 2 degrees is considered from a scientific perspective, a critical threshold where things go from like not great to potentially really bad, and also where economists say that those social costs of carbon actually really start to increase. We need to be reducing our emissions, and this doesn't get us there. And even the more stringent interpretation of that agreement was that it would be hold it to 1.5 degrees, which is even more ambitious. So we're not on track, even with those good stories. And even here in the US in many ways is on a nice trajectory. This is the US greenhouse gas emissions from 2005 until now. They've actually been declining. With our current policies, we expect a reduction between 24 and 35% from 2005 levels. It's always very confusing because there's always an old year that you use as your benchmark. And there's also, you can see the consequences of the Inflation Reduction Act, of which I'll talk about a little more in a few minutes. This was the law passed in 2012 with a whole host of provisions to try to promote clean energy and renewable energy in the US. And this drops us down. But look, this number here, even here, this reduction of emissions from 50 to 52% is what the US agreed to as part of the Paris Agreement. So even with our current policies, even the US, which is trying to be like a model leader, is falling short of those agreements that we actually set. So how do we do it? What do we do going forward? And how do we actually think about addressing this problem? Well, the answer that I'm going to give to you is an answer that every economist would give to you as what you would refer to as our first best solution, the recommendation. I told you before that climate change is a market failure because there's external costs that are being imposed on society that in the private markets are not accounted for. The way to correct for that is to get the prices right. And the most efficient way to correct that is to use something called a carbon fee. And I put tax here because I know tax causes some people to have very strong reactions. And that's okay, but let's hold that, put that on hold for a minute and just listen to the argument here about, it is true, I will argue that a carbon tax or a carbon fee is actually the most free market-oriented way to address this problem. And the reason is because it sets the incentives to internalize that externality, but what it doesn't do is have the government pick and choose the winners and decide what to do in order to advance. It lets the marketplace take advantage. If you impose a tax, say a $50 tax per ton on CO2, you unleash tremendous entrepreneurial activity to try to come up with ways to reduce the carbon content of everything. Why? Because if you solve that problem, you don't have to pay the tax. And the government doesn't have to figure out what you should do or tell anybody what to do. You let the market take care of it. The other thing that a carbon fee can create is it creates revenue. And a way that you could address this revenue concerns are two ways. One is you could have dividend payments where you just pay out these benefits, collect up the revenue, and return it to people in actual checks. Everybody could get the same amount back. Low-income people could get more than high-income people. We could debate and talk about how to do that entirely, but this is one feature of the policy where it's actually not as costly as you think because the money just comes back, but you've tuned the incentives to create a way to reduce emissions in an efficient way. The other thing you could do, and this is actually the policy that I currently like, is you have a source of revenue. What you can do is reduce other taxes, reduce your payroll taxes, reduce property taxes, reduce all these other taxes that have negative consequences that distort the economy, tax bad things like CO2 emissions, and don't tax good things like people's labor or income generating, and you actually get as referred to as a double dividend. You get two benefits. You reduce the externality, and you reduce distorting the economy by having other taxes. And believe it or not, there's quite a bit of bipartisan support for these types of policies. The other argument in favor of it is it simplifies regulations. I focus on this like for a living, but I couldn't even tell you how many different types of state level, federal level, environmental, climate policies we have, many of which are overlapping and counterproductive, and one undoes the other, and we layer one on top of another. If you had this approach, you could eliminate them all. It's a very clean and parsimonious policy. If you pursue it, you also need to have a border adjustment so that you don't disadvantage our own industries with other industries from other countries in terms of international trade. All of this stuff has been laid out, studied, and the proposals are actually out there. This is not the approach that we use. We use another approach so far. Sorry. This is not just pie in the sky what I talked about. This is actually a graph where we have carbon pricing around the world now. The maroon tells you places that have it under consideration. The blue are countries that actually have carbon taxes in place right now. The green are ones that have emission trading systems. These are like cap and trade programs, which are quite similar, create similar incentives to carbon taxes. And then there's places that have a combination of both. And if you look at this, okay, you see that in the places that have these policies, the average price per ton is $6 per ton that they're actually paying. And in many ways, this seems like progress, but it turns out that last night, when I was putting together these slides, my 9-year-old son came in and he was looking at this, and he's an inquisitive little guy, and he saw this. He's like, $6 per ton, is that like a lot? I was like, well, many people sort of argue that this is a great thing because we actually have a policy in place and people are having to pay for the externality. But remember those numbers that I showed you before, about $187 per ton are the actual costs, and it's quite low. And I actually showed that graph to him, and I explained it to him, and he was a 9-year-old. And then when he said he looked at that $6 number, this was his reaction. What? We learn about this as like this major problem, and right now, people are paying $6 per ton. You're saying they're harming the world by $190 per ton. What's going on? Well, this is the challenge that we sort of face. These are the future generations of thinking about these issues, and I don't have a good answer, except I need to work harder to try to bring those numbers more in balance. What do we actually do right now? Well, the big policy that passed in the US here in 2022 is the Inflation Reduction Act. So I'll just go through a couple things to let you know what's in it, because it's a sprawling, complicated thing. But this basically provides $370 billion for climate and clean energy. Unlike a tax that generates revenue, this is one that creates incentives but actually costs revenue. So now we need to raise tax revenue in order to pay these subsidies. And those are quite different, but why is this the approach that's undertaken? I think the political economy is that subsidies are just as costly to us in many ways, but it's more obscure and more difficult, and the electorate doesn't actually face those costs directly. It's sort of like buried in like future revenue raising potential. Nevertheless, I think it's important to recognize that these are quite similar incidents, but I do think that the tax policy has benefits. So what does the Inflation Reduction Act contain? Basically, there are clean energy incentives and funding. So this is investments, tax credits for solar, wind, and critical minerals that are needed in the production of batteries and energy. Clean energy innovation. These are funding and programs to try to have breakthrough technologies in order to bring down those costs even more and find more efficient ways to transport electricity and actually store it. Clean energy manufacturing, so these are credits for facilities that make wind turbines and solar panels. There's a lot of provisions in this act that actually tries to make it so that these industries are in the US and we're not actually subsidizing just this capacity in other countries. Clean fuels and vehicles, there's tremendous amounts of money to increase the infrastructure for being able to charge electric cars and to subsidize the purchase of electric cars, with the rationale being that their emissions is less than they are from fossil fuel vehicles. And then there's carbon reduction and management, and this is carbon capture and sequestration. Many sort of believe that even in the best case scenario, if we reduce our emissions, that in the future we're going to be in a situation where we actually need to be sucking carbon out of the air and storing it, because we're going to have built up so much stock. So this is what the Inflation Reduction Act contains, and has been heralded as a policy, at least in its ambition, is the biggest federal policy in the US to address this problem. I'm going to close and leave time for some questions and answer by just having a couple of comments about like what can you do or what can we do. And here I just have two images. The top one is an image that sort of suggests that we could all go, and many of you probably do, particularly given that we have a sample here from Garden Club members. We can actually make decisions to buy environmentally friendly goods and services. Basically try to do our part as consumers or have behavioral adjustments that try to minimize our impact on this issue. And I think that is important, is useful, and we should continue to do that and try to be informed about those decisions that we make. I think the big part, another contribution of it, is actually not necessarily the environmental contribution that those behaviors actually have themselves, but the way that they build awareness and have people thinking about these issues. And about 8 years ago, a colleague and co-author of mine named Gernot Wagner, who's at the Columbia Business School, he wrote a book that didn't receive a lot of attention, but I think is really important. And the title was, "But Will the Planet Notice?" And what he meant by that title in that book was we go and we do these behaviors and we sort of all have a very infinitesimal small contribution on the environment and on this issue. Of course, if everybody did it, those contributions could be big, but I don't think everybody is like a Garden Club member in terms of making their decisions, or the typical student that we have at the Yale School of the Environment that are focused on these issues. And the question that he's getting at is, will the planet notice when us individuals make their behavioral change? And I'll suggest that I think that it will make a difference and it may make us feel good, but it's not going to even come close to making the kinds of differences that we really need. What we need is political engagement in civic organizations that try to change the rules of the game and not rely on voluntary behavior of individuals. And this is applicable at the federal level, the state level, and the local level. I was hearing about the Garden Club's involvement in some sort of like adaptation plans and sort of flood resiliency here in Stonington. That is wonderful, a civic organization trying to affect the political process. And that is where we could, if I could take all of the money that people spend on environmentally friendly goods and services and redirect that towards people supporting candidates that have a pro-environmental or climate activity, we would be in a much better place today than those behaviors. I don't want to sort of poo-poo those behaviors and don't say them, but I want to say is those should be complements rather than substitutes for actual engagement, so that we don't get this warm glow and feel like we're doing our part because we bought organic things. We need to be involved. And I just want to be very clear in my last comment here, this is also not a partisan statement, because you might be listening and thinking that this is in support of maybe Democrats who have a more forward-leaning climate stance. I would say it's even less important to do that. What's more important is if you lean Republican, but you care about this issue, getting involved and having those actually support and think about these issues is really where we actually need the help. And so with that, I'll end and say that thank you, and I'm happy to take any questions, comments, or concerns.